Hello learners, this is Priyadarshi Shubhakant. Once again I welcome all of you to my sessions on CNC milling machines, as we are discussing regarding the different types of program. And in today's session what we'll be discussing, now we'll be having the discussions on datum offsetting program. So in this what happens, you will write a single program for a particular profile and later on we can repeat that one as per offsetting the datum. So how to do that one we'll be learning in today's CNC machining operation 2. So without wasting much of the time, let us start today's session. So now we'll start with the datum shift program, and here we can see, just let me explain you why we use this datum shift program. Now generally here we can see 4 square we have cut it. The radius it is been shown because it is of the radius of the tool. Don't think that we need to use G02 and G03. How much cutter diameter we'll be using, according to that the radius value, the radius will be provided. I can say the fillet will be provided in the corner. So here what happens, simple square profile we have to make it, that is 20 into 20 I have taken it. So this square 20 into 20 I have to make it into 4 times, as you can see over here. And to do that one I need not to write the program repeatedly. What we can do, now I can write a sub program for this particularly first square and I'll shift the datum of the particular program. So accordingly what happens, now this 4 squares will be made. That means I'll write the program for 1 square, other 3 squares I'll shift the datum for them. Need not to write the coordinates once again for them. So first of all, starting with the square 20 into 20 where I have written, I'll write the sub program first. You can see that is 00015. I have taken the program name and it's a sub program. G28, G91, Z0, all of you know that one. It's a homing in Z axis. Then G00, G54, G80, G90, G40 and X0, Y0. We are taking the center portion of the particular square 20 into 20. From there how it will move on, we'll see in the program. And M03S700 is for your spindle rotation in clockwise direction with a RPM of 700. Then next G00Z 5.0 is your safety height and #1 is equal to 0.2. Then next in N1 I have given that #1 as the first depth of cut, I can say. Next G01, G41, D1, X10, Y0, F is 560 and here G41 we are using because tool nose radius compensation is there in left hand side direction. And D1 is what? It is the diameter of the tool that we have given in your tool library in D1, that is dia 12. Then X10 and Y0 is the first coordinate. It will move from X0, Y0 as you can see with a feed rate of 560 mm per minute. The next G01, X10, Y10 is the other coordinate point. Then G01, X minus 10, Y10 is the other coordinate. G01, X minus 10, Y minus 10. G01, X10, Y minus 10. G01, X10, Y 5.0. G01, X0, Y0 and tool nose radius compensation cancel with G40. So these are the coordinates for cutting the square only. You can see it. I have not shown you exactly because this is a very small thing now at the moment for you, because already you have done so many programs, so need not to show you that where are the different types of coordinate points. And here you can see it, there are the coordinate points. You can calculate it by your own self to cut this particular square pocket. Then once it is completed, #1 is equal to #1 plus 0.2. and next moving on to the logic, that is if #1 is less than 1 mm then go to 1. So I have taken the depth of the pocket over here, I will be cutting, that is 1 mm. And then next G00Z 5.0 safety height. Then next G28, G91, Z0, that is homing in Z axis. And M99 is your sub program end. Always remember, M99 is for your sub program end. Now I'll go for the main program, in which I'll call this sub program and repeatedly will be changing the datum and will be doing the program. So for that, let us see now in the main program what we need to write. Now G28, G91 homing always to be done as per Z axis. Then G00, G54, G80, G90, G40 and X0, Y0. M03S700 we have given, that is the RPM for the particular tool. And here you can see G00Z 5.0 is the safety height from the surface of the job. M08 is coolant on. G52 you can see that is datum shift. And here X20, Y20 is the first point, already we have given over there. The next M98, P15, That means what happens, M98 is sub program call, and which program it will go? It will go to the P15. I have given P15 means O0015 was the program name. So program name which P is their program, that is 15 number program, because 00 it will not consider. If you are writing P0015 is also no problem. So P15 program it will consider and it will call that one. And here once the sub program is completed, again it will shift that one, the particular coordinate will be shipped to which one? G52 will be again used to ship the coordinate in x minus 20 and y 20, you can see. And again the sub program call will be there, P0015 here I have used. So both, either P15 you can use or P0015 you can use. And next, once the program is completed, sub program, again we have to shift it in x minus 20 and y minus 20, I can say that one. And again we'll call the sub program and we'll do it. Then once again it is completed, then we'll go for the G52 x20 and minus 20, and there we'll be using the same program, that is M98 P0015, same program number will be using. And once it is completed, it will go to G00 Z5.0, that is the safety height. Then G52 and G90, once again we have to use it. Then M05 M09 is your spindle stop and coolant off respectively. G28 G91 Z0 is homing in Z axis. M30 is your main program end. So this is the program regarding the datum shift. Now the same program will be doing it, and let us see how it is cutting the profile. So first of all, the same thing we need to do it. Let us go to the CNC machine, go to the edit mode and write the program. As you can see over here, the similar way we have to insert the program and we have to write it down. We need to write both the programs, the sub program as well as the main program. And once the program is written, once the program is completed, we'll go to the graph and we'll see the graph whether it is okay or not. For the sub program, we'll check the graph. As you can see over here, let us check whether the square pocket of 20 into 20 was okay or not. You can see over here the movement. According to this, we have given it and exactly it's perfect. And here you can see once the graph is okay, such type of 4 pockets will be cut. So now let us start the machine now. We'll go to the auto continuous mode and we'll press the cycle start button, and gradually we'll increase the feed override button. And you can see, so the first program it will be done. You can see here we are using a end mill of dia 12. So here we can see the program we have written, and it is cutting in the particular datum shift, that is x20 and y20. It was cut, then again it moved to the x minus 20 and y20. Now the profile is being cut. The same profile is there, but the only dimension is changed. Next, it is coming down towards x minus 20 and y minus 20. The datum is shifted and it is cutting the same profile. And now it is going for x20 and y minus 20. In this particular coordinate, it will be cutting the same profile. So here what happens, once you write the profile program, you can repeat it the same profile as per the coordinates, and you can see the already the profile is been cut and the machine is getting homed in its Z axis. Now let us see the profile. It is perfectly cut. How much the programming we have done, accordingly it is cut. That was all regarding datum offsetting program in today's session. Hope you liked it, and that those were most of the basic CNC programs what we generally perform on a CNC milling machines. So that was all regarding the programs we had in this total course package. And in upcoming session, the last session, it will be there for the CNC milling machines, in which we'll be discussing regarding the DNC program. So till then, have a good time ahead and wait for our next session. Thank you all.